So I guess you know the tradition of our trans of female slides, so I want to do that as well. And I have prepared one. Oh, oopsie, I think the wrong picture got in here, so let's quickly correct that. In all seriousness, though, I want to advertise not a single woman, but an organization that aims to help close the DevOps gender gap, as they say themselves. They want to inspire the future leaders of the DevOps world. So it's a platform of women who try to amplify the voices of women in DevOps, who try to work with and towards minority groups within DevOps, try to break down the barriers, drive positive change. That's what they say on the website. And I think they have now in excess of 2,000 members already. And it's definitely a case that we should all take a look at and try to support in any shape, way, or form we can. So there's the link on the slides, womenindevops.com. So take a few minutes out of your day and visit the website and see if you can do anything to support that cause. Okay, with that being said, let's jump right to it. The topic today is continuous integration, what it is, what it's not, and what it could be. Well, on the surface of it, this sounds like a very academic discussion to debate whether something is continuous or not, whether it's being integrated or not, whether the integration is continuous or not. But I think it's important to have that discussion, not at the end of the day to be right about whether something is continuous integration or not, but to have the discussion about the processes and about the tools and about all the aspects and shareholders that are involved with this whole topic of automation. And I've read up quite a bit on the topic in the last weeks and days, and it seems that there has been some semantic diffusion, which means that a term was originally coined, but then later on got kind of watered down. And I find it very interesting to look at the variations of the topic and see what we can get out of that. I want to introduce myself very briefly. My name is Jörg Hamper. I'm an Austrian living in Germany now for nearly 15 years. I've started programming in LabVIEW when I moved to Germany, so roughly 15 years ago. And meanwhile, I'm running my own small company. We're a company of 5 at the moment, looking to grow in the next few months. And what we do is we work with teams of developers to increase the quality of their software through improved development processes. So that's the tagline, that's marketing speak. And what it means is that we like to work together with our customers, taking on work packages from our customers, sitting side by side with them and trying to get work done together with them. And at the same time, we try to instill best practices. We try to show them how to make their lives easier when using LabVIEW and the NI toolchain to get their work done. So we take on work packages, but we also give trainings, both NI trainings and custom ones. We are giving workshops, and we are also the first German NI Center of Excellence. And the Center of Excellence reflects a lot of the good practices that we want to use and that we want to teach throughout our days. So the agenda for today is we will talk about automation. We will, of course, talk about continuous integration, delivery, deployment. We will then look at different workflows or branching models, which might or might not make up the continuous integration process itself. If there is time left, I have prepared some more slides talking a little bit about supporting technologies, CI providers, virtualization containers, just to give a few keywords for you guys to think about and to look into the different technologies that are available at the moment. And then if there's really more time at the end, I can show a little bit about how we use all of these technologies or some of these technologies in our daily life with our customers or for our own projects and products. Some words that I also want to spend on the caveats of this presentation. Of course, this is my personal point of view. As I said, I've read up on the topic, of course. We have been doing this for quite a few years now, but still this is the reality that we live in as a software service provider. We usually are working on projects, not on products. That makes a huge difference, I think. So keep that in mind. The second thing is I'll be focusing on small teams collaborating with each other. So if you're working on your own, if you're a lone wolf, many of these processes and many of these techniques will be beneficial for you. But the aim of this presentation is with small teams in mind, neither lone wolves nor huge software development departments, which are kind of unusual in our LabVIEW world, I would say. I will focus on decentralized source code control, Git, as it says here. So this is the weapon of our choice. And of course, all of these or many of these processes and workflows that we will look at kind of come from the Git world, even though they are easily applicable to other source code control systems as well. And of course, the focus is on the LabVIEW world. Obviously, we are all, for the sake of this event here, I think it's safe to say that we are all moving in the LabVIEW world. So I expect that we face similar realities in our daily jobs. Technical and human aspects, as well as the nature of projects. Okay, so I'd like to start with a audience exercise, why automation, and I hope that this works out. So I've prepared a polling tool. So if you could go to menti.com and use the code 21289313. It's on the top of the slide. I hope it's you can read it. And if you want to do that and type in whatever comes to your mind when you think about automation in a software sense. Josh is asking, am I sharing? Can you elaborate? Yeah, somebody found it. So if you go to, thank you, Alexander and Katikaya. If you go to www.menti.com and then enter the code that the colleagues just shared, this works awesomely, I gotta say. So already lots of stuff coming in here. I can see lazy. Interestingly, that's the hugest so far. Time saving, also a bigger one. I can read early detection, easy reuse, repetition, consistency, repeatability. So all the nice words, I think, that we can think of. I see Git, I see less work, DevOps, of course, code quality. This is an awesome collection of ideas already. I will use all of them in the future in our marketing slides. So thanks already for that. And I'll have to keep an eye on the watch, not to make this too long. So I think it's safe to say that time saving is the most important one, it seems. It's fast, it's repeatable, code quality, as we said before. So from what I can see, no surprising entries here so far. It's helping unskilled, that's very good. It's applying standards, quality, it's cost effective, it saves time, less errors. So all the things that we would expect. Awesome. So let's go back to the slide set and see what did we come up with. So first of all, automation brings greatly improved collaboration. Automation increases transparency and accountability for your team. What do I mean with that? I think if you automate stuff, hopefully you have something that you can automate, meaning a process. And if everybody buys into the same process and if everybody uses the same way of working, the same pipeline, and results are being generated kind of like objectively, then it's more easy to see the results of our actions. So if we provide some code, it's being automatically processed, we see the results. This makes me accountable for whatever I provided. So I think this is beneficial to collaboration, at least in our experience. Fast issue detection and isolation, we've seen kind of these buzzwords on the other slides too. Automation makes issues readily apparent upon building. We'll talk about it later on, but of course, once we automate our tools and our tests and maybe even our build system, issues will pop up immediately upon these build processes, upon these automation processes being executed. So that helps a lot, of course. Better use of resources, that's a no-brainer. Automation frees up our time. We can focus on tasks that are more engaging, that are more interesting, so we can put our energy where it can create the biggest benefit. Shorter delivery cycles. Depending on what we automate, that might be closer to reality or not so close to it. But even if we automate like only the testing, that will already help us find out issues faster, so we can fix them faster. So again, probably the product will reach the customer earlier. And then it avoids burnout because automation improves team morale and satisfaction. That kind of aligns with the better use of resources. Of course, if we don't need to do the tedious, the boring, the repetitious stuff, that makes our lives happier, I would say. So what's a prerequisite for automation? The most important one, probably, in my point of view, I would say it's a process or a workflow. So if we don't have a process or a workflow, we can't really automate anything. And the old truth is that if you have a shitty process, automating it will make things worse, not better. So really, it's important to figure out what is a good process to automate before we look in the automation. Not only looking at what works for us as a team or for our projects, for our customers, also how are the automation tools supposed to be used? How were with which processes or workflows in mind were they built to be used in the right way? Do we leverage them in a way that we get the most out of them? So the process and the workflow, they come first before we can even think about automation. Another thing that's important for automation is infrastructure, of course. So depending on which level of automation we talk about, we will need different levels of infrastructure. Talking about running a unit test on my machine locally, of course, I only need my developer PC and some software tool that helps me with that. When it comes to centralized source code control, centralized repositories, build servers being involved, even distributing our packages, our applications somewhere, maybe even deploying them, the bigger we span the arc, the more infrastructure we need. And that is sometimes also an issue, because depending on the budget that we have, depending on the IT departments, depending on what's possible for a customer or even in our own infrastructure, that might not be an obstacle that we need to work on. So with all these things in our minds, I have another question for you guys. What is CI? What is continuous integration for you? So please go again to menti.com. You'll have to use a different code this time. That's due to me not being able to figure out how to do it differently. So the code this time is 29846593. So if you could go there. Thanks, guys. Thanks for typing it in so I can save it. So let's see what comes up here. So what do you people associate with the term continuous integration? That'd be interesting. I hope it works just as nicely as the last time. See what happens. I'm watching the time. Okay. Stuff comes rolling in, perfect. Okay, what do we see yet? Nothing yet. That's a blank slate. That's good. Thanks for attending my presentation. Automatic build, I can see VI analyzer, Jenkins, of course, repeated flow maintenance, clearing bugs, flexibility, improve the software infrastructure, automating the builds, sandwich, synthesizing. These are very interesting, I think. Fast builds, of course, Git again popping up, delivery, I can see here, agile, I can see. Backwards compatibility, that's interesting. Parts work together. Reliability, short cycles, that's good. Improving the software, fewer configuration errors, automatic testing, very important. Daily build, daily release, that's an interesting one. We'll be talking about that. Test sequence analyzer. What did I do wrong? That's very good. Okay, thank you. That's enough probably. So let's see, what is CI? Let's be very analytic, deterministic, very academic, continuous. Let's take the definition of that. Actually, I forgot now. I think it was the Oxford Dictionary that I looked this up in. I need to add the URL here, the source. So continuous means without a pause or interruption. So let's keep that in mind. For this discussion, it is very important to Cambridge Dictionary. Okay, perfect. Thanks, Spencer. So this slide is a screenshot taken from the Cambridge Dictionary. I will add the source, the URL later to the slide set. Again, continuous, the word means without a pause or interruption. Ongoing, frequently maybe. So that's for the sake of this discussion, for the sake of this presentation, I think it's important that we keep that in mind. The other thing is integration. Again, the textbook definition, combining two or more things, and very important, in an effective way. That's also interesting. So integration means, again, going back to the first slide, continuous without a pause or interruption, integration, combining two or things in an effective way. So nowhere here does it say automated, nowhere does it say build server, nowhere does it say anything about that. And I find that very interesting. And when the term continuous integration first popped up, that was not the focus of people. It was not to automate anything, although that might be a necessity for that, but we'll get to that later on. So again, continuous integration without a pause, combining two or more things in an effective way. Okay, so let's see. If we look at a source code development history, or for those of you familiar with these graphics, of course, I'm talking about a branch here already. So I'm looking at a kind of source code control system. Doesn't really matter which one. And then we have a number of commits. So a commit would be the action of saving one version or one set of files into my source code control system. So if I do that a few times, I will get these bubbles here, and they are connected, so I know which one comes after the next, or actually probably the other way around, which one came before the most recent one. So I have this this train of actions here. Usually we call that a branch. Many source code control systems use the term branch for something maybe more specific, but for this presentation here, I'm talking about a branch, and I'm meaning a particular sequence of commits to the code base. And the tip, which is usually called the head of the branch, is then the latest commit in that sequence. So continuous integration. If I type away, or in our case, if I click away the whole day, I make my changes in LabVIEW, I commit frequently, this is what I get here. I would continuously without stopping, integrate. I would like save my changes to the repository. So this could be one scenario, one definition for continuous integration, I would argue, because we would continuously integrate our changes into the mainline. And mainline is a word that's being used in that context, mainline or master or trunk-based development. This is one workflow, one methodology maybe for going about software development. Lots of books, websites. There's this trunk-based development.com website where you can read up on this. So of course, this is an oversimplification, but again, what could be the problems with this thing here? Any ideas here? What could be problems? So let's see, yet another code. I'm sure somebody will type it in. It's 33478061. I'll wait for a few seconds for things to pop up here. I think there's actually a game in it. Who is the first to type in the code into the chat? Congrats, Eric. Okay, this works for a single developer. Merge hell. Everything is a problem. Oh my. Nothing is a problem. That's also interesting. So if I were to type in an answer, it probably would be it depends, but of course we want to look at all the angles that we have here. Single developers, teams of developers, centralized, decentralized source code systems, etc., etc. Too many bugs at once. People equal problems. That's a good one. God level programming. Yes. Rebasing. Well, that's an advanced term here. Feature test. Where would we test the features? Too many bugs. Team collaboration might be difficult here. And still the merge issue, the word merge is the biggest one at the center of the problems here. Tough collaboration, yes, I think I will agree to that one. Conflicts, of course, merge conflicts. Being behind the head, yes, that's difficult. For a lone wolf, it's great. Might or might not be the fact. Okay. So the merge topic is the biggest one here. We can see that. So let's see. Multiple developers or even ideas, I would say, might be a problem. So either if there are multiple developers who want to collaborate, or even if I'm a lone wolf, but I want to follow different paths of thought, different ideas at the same time, I might want to be able to have a not finished version of something in parallel to what my main product is here. So think about multiple people pushing to the same repository, no matter if it's centralized or decentralized. Yes, there's a problem. So it seems like it's not enough to just commit to the mainline continuously. After all, we need some parallelism, right? So what can you do about that? Looking at our branch workflow schematics, we can introduce feature branches. Okay, thank you, Tim. So feature branches, what's that? We don't rely on a single branch, but we create the possibility to maintain different versions, different variations, different features in parallel, so that we have a way to be able to use source code control, but not collide with each other all the time. And looking at these directed acyclic graphs, as they are called, we can see here. I'm not sure, can you see my mouse? I think so, right? Somebody could confirm quickly. Yeah, thank you. Okay, so this used to be our main line here, right? So we have our main branch, and now what we can do is we can create a branch. Like literally, we would branch from the main line, which means we have a second like sequence of commits, and these are maintained separately from our main line. So if I want to implement a new feature, I could create my new feature branch. I could work on that branch. I could push it. I could save it in the source code control system, and I would not affect other people working on the main line. And other team members can do the same thing. They can create their own feature branches. So there's not a limit to the number of feature branches we can have in parallel, although it's not good to have too many of them. We'll get to that. But what we can do here is we can have something that we can work on without disturbing, without breaking stuff for other people. So that's good, I think. Of course, we saw the word merge on the other slide. This introduces a new level of problems because now we need to think of if this came here and then other stuff is merged into here, how can we combine all of these without breaking stuff? Yet another problem. Another thing is once I'm not working on my own anymore, if I'm not the lone wolf, if different people are involved, we saw it on the poll, people are problems, then we need to have some kind of agreement on how to work. We need to maybe apply the same style guides, the same rules. We want everybody to test their stuff so that it doesn't break our application once we merge the features back into the main line. So what can we do about that? Of course, the most interesting stuff of this whole presentation probably, let's do automated tests. So not thinking about how to do that and which infrastructure we need, etc. What we can do is we can say whenever somebody shares his or her work with the team through the repository, we can trigger some automated stuff. We can run some tests. This could be unit tests, could be static code analysis, could be all sorts of things. So we can run these tests automatically and give some feedback to the person who shared their changes. So I think that's a very good thing. We will agree on that. It's a good thing because we need to have some process, otherwise we can't automate. It's a good thing because we do have tests, which is not like a given. And it is good because we gain knowledge about what the current status of our repository, of our application, of our project is. So that's nice, I would say. Okay. So what comes next? As we are building all the time, can we deliver the product as well? I mean, that's also quite obvious, saying that if we run the tools, if we run tests, we probably don't only want to run tests to figure out if our unit tests pass and if the static code analysis works fine. Most of all, we want to build the application to make sure that we can still build it. It's not broken. We can still generate whatever we want to generate. And while we're doing that, we already have the result in our hands. So why not use that? And of course, we can do that. We can do continuous delivery. So there's a little bit of a blurry line in how people use the term continuous delivery. Not as much as with continuous integration, which usually is a placeholder for anything that happens automatically on a server. With continuous delivery, some people talk about delivering the changes into the main repository, but I think more often it's used to mean that we take the results that were being built automatically and put them somewhere, share them with our team, with our customers, something like that. So in our sequence of steps here, we can see developers do some work, they push them to the source control server, triggers the automation, the build server does all the tests, eventually it might build the actual application or package, and then we just copy it somewhere. So onto a distribution platform, maybe a network share, the cloud, whatever, some place that we can find later on. So we're still in the mindset of doing things continually, right? Continuously. So this would mean that all the time these things would be happening. Whenever any of the team members pushes stuff, we would trigger the automation, it would run the tests, it would build stuff and deliver it somewhere, which means that we would end up with lots of packages, I would think. So how do we know now which version to use? I mean, which ones of these should I actually take and then give to my customer or download to my PXI system and production system or whatever? So which of the delivered packages is the right one? Well, of course, there's a solution to that. We can go into integration branches. So what this means now is that we have not only the main line and the feature branches, we have yet one more place here, which is called the integration branch. And this means that we will work off of this branch. We will integrate changes. We will integrate the features back into this branch, but we don't necessarily deliver each of these commits here on our integration branch. We still are able to pick some version of this and integrate that or merge that into our main line. So we have a very precise idea of which are the actual things, the actual collections of features that I want to deploy. So this means this is the first time that we have a separation between doing something continuously and doing other things not as continuously as the rest. Because of course we want for all of these commits, at least for the merge commits where we integrate features into our integration branch, there we want to run stuff. We want to run the tests. We want to know everything's still working, nothing is broken, of course. We don't necessarily want to take each of these and create a new version, a new package, a new supplyable thing out of it, right? So this, I would argue, is not as continuous as this stuff that's happening down here. But it enables us to pick the stuff that we want to actually give to our customers, use in our systems, install on our test stands or whatever. So this separation, I think, is very important. And we will come back to that later on as well. Okay, so now that we figured that out, what else? Now that we know everything's working and we always know what we want to release, why not roll it out automatically? So of course, continuous deployment, the next step. So we have everything in place again. Changes are being tested. Only if the tests pass, we will build stuff and deliver it to some platform. Plus, if we know exactly which versions we want to create at which point in time, then we might or might not, but we might be able to actually deploy these things to our customers, to the production systems, somewhere to the cloud, depending on the piece of software that we're working on. So, of course, this is what we all want, right? So this is heaven. So here's the cat picture. Everybody wants to have a cat picture. So this is what we would feel like if this whole scenario was reality, I would say. So let's look at that cat for a second and feel just as blissful as the cat is feeling while I'm reading the questions in the chat. I see Chris asking, but Alexander already answered it. How do you manage bug fixes? So I will maybe get into that later on if we have time, Eric. Alexander already jumped the gun and shared the picture of the more complex example. So I will show that later on maybe. Okay, so coming back to the cat, everything is good, right? Except not sure if it is. So let's talk about obstacles that might be in this nice little picture that we saw before. So yet another Paul here, who is first to type in the code 64720156. And the question is for this continuous integration, Eric again, continuous integration, continuous delivery, continuous deployment for this nice picture where we say, we test everything, if it passes, we deliver it and straight on deploy it to somewhere. What could possibly go wrong here? Again, the merge conflicts. Yes, that as well. Let's see how many people pick the Martian. The broken arrow, so we cannot build, that might be a problem. Stability might be a problem, okay. Let's wait for a few more. Come on, people. Give me some more ideas here to work off of. I know we went very quickly through the whole thing, but time is of the essence. So let's see what comes from this. Thread management, that's interesting. Different configurations, yes. Building for FPGA in real time. We haven't talked about that. A buggy feature, that is interesting. So what do we do if we introduce a bug that we didn't catch with our test suite? Parallel development still, conflicting dependencies, yes. A clean build machine, we have to look into that. We have to take care of that. Infrastructure budget, that's a very important one. Poor development, of course, that's never helpful. Broken app, that's not good. Communication is key as always. Automating versions, that might be difficult. Okay. So let's see, the merge is again and still in the center of everything. So before we get to that, let's look at some more slides and see, look at the ideas that I've prepared. Okay. So thanks for the answers. So let's start with the thing that we started off, the trunk-based development. So in an ideal world, we only have a single branch. Everybody works on that branch and nothing bad happens, right? And I'm really not trying to bash trunk-based development or say anything bad about the website. I'm really only showing that it's not as simple, or I want to show that it's not as simple and as straightforward as some people make it out to be. So the claims on the website are, you should do trunk-based development instead of Git Flow and other branching models that feature multiple long-running branches. Okay, so no long-running feature branches. That's one thing, okay. You can either do a direct to trunk commit push for small teams or a pull request workflow as long as those feature branches are short-lived and the product of a single person. So again, short-lived feature branches. So even with these two sentences, the first one says we should not do Git Flow or other branching models, but it implies that we might still need feature branches. So a single branch seems to be insufficient for what we want to achieve. And if we scroll down, if we scroll further down on the website, there is some caveats, and these are interesting. I'm not going to read everything here, but it's still interesting to look at that because depending on the team size and the rate of commits, short-lived feature branches are used for code review and build checking, but not artifact creation or publication. So they already say feature branch is a good thing. It should be short-lived, not long-lived. Okay. Depending on the intended release cadence, that's an interesting one as well. There may be release branches that are cut from the trunk on a just-in-time basis. They are hardened before a release, and those branches are deleted sometime after release. Alternatively, there may also be no release branches if the team is releasing from trunk. So without getting into the details of all this, there's already a lot of complexity in there. So it's not as straightforward as it's made out to be on like the first 5 sentences when you look into trunk-based development, either on Wikipedia or anywhere else. Teams should become adept with the related branch by abstraction technique for longer to achieve changes and use feature flags in day-to-day development. Don't get me started with feature flags. So I would never use a feature flag. That's me personally, again, I'm being dogmatic here. But a feature flag is something that you use to mask out a feature that you already have in your application. So just to maybe like a conditional disable structure or something like that. So I can see how this is, how we would want to have that in our application. I know we use it sometimes for some stuff, but I don't think that like we would want to see our OVIs being flooded with conditional disable structures. Then another thing, if you have more than a couple of developers, how much is that? You're going to need to hook up a build server to verify that their commits have not broken the build. Okay, yeah. So that's always a good thing, I would say. So again, I'm not bashing because some of these things work great, others not so great, but we can see it's not as simple. And the next problem that we have is LabVIEW. So what are our LabVIEW realities? I should have made a question out of that. I forgot to do that. So let's just dive into it. LabVIEW users are usually not computer scientists. So for the customers that we work with, usually LabVIEW users are engineers. They have to solve some very complex problems, and software is just one of the things that they need to be mastering for solving their challenges. Very often, they have no prior knowledge about software engineering processes, so they have a hard time doing all the right things if nobody shows them or helps them. So I think that's, I hope you'll agree that this is a reality in the LabVIEW world. And if not, please tell me so in the chat. Just reading James's comment. So James is saying the benefits of feature flags is you're still doing integration, making sure the code fits together and doesn't break other elements, but without exposing incomplete features to the user. Yes, but while that's true, I'm not so sure that this doesn't come with its own set of challenges, which nobody said. So nobody claims that this is the golden bullet, the silver bullet, but I'm just highlighting the fact that using feature flags comes with a different set of challenges. You might avoid branches or merging, whatever, but you still have to maintain that in your code. And James, please let me know if I'm wrong on that one. Ethan says, to me, the point of trunk-based development is that branches should be a tool to be used and then promptly discarded on an as-needed basis rather than a fundamental, always-on component of development. Not so much about never making branches. That sounds about right. So, okay, let me continue. Next problem with LabVIEW is projects are usually short-lived. Again, that's our reality. But for the most part, LabVIEW projects, I don't know, range about like a few weeks to a few months, maybe. It might be that we come back to the same test stand or whatever and have to implement additional features, maybe 1 or 2 years down the line. So very rarely do we work on a product. And I think due to that fact, and also due to the whole approach or the way it's being done at many companies, there's usually not a budget for infrastructure and for best practices. So usually you get money for developing the code. You don't really get money for setting up a build server. You probably don't get money for writing your own unit tests or for maybe even applying the analyzer. So for the larger part of where LabVIEW is being used, I think these are realities that make our lives harder when trying to do best practices. The language is not text-based, for better or worse. For the most part, for the better, because we like the graphic way of programming, but it makes it difficult to apply text-focused best practices. And lots of the tools, lots of the processes, they are being built for, or at least with text-based languages in mind. So we all know that merging in LabVIEW, merging VIs is more difficult than merging text files. That's just the truth. And I think this truth applies to different aspects of software development. And then the traditional project landscape, just as a side comment on the continuous deployment, I can't think of a single of our projects or customers where continuous deployment would work. Continuous deployment. Of course, automated deployment, it's a different story. Manually automated deployment, I can see that. But the way that we would think about like just multiple times a day deploying stuff somewhere, that's not something that we can do anywhere in our daily lives. Again, turning to the chat window for a second. Okay, yeah, Chris, well, if you have time, we'll get back to the merging develop back into the feature before then finishing. NHG would have been a good start. Still probably with its own set of problems, because tools that can use, that can merge text might still create files that are not semantically correct after all the lines have been combined. But I think that would have been a point where LabVIEW, wherein I might have been able to supply tools that help with that. Alexander says that it's not shown in the diagrams. I did not show it intentionally because we're not, I haven't talked about these like advanced flows. I always try to avoid branching, but there are 2 rules. 1, at least 1 commit a day, and 2, only working code is allowed in trunk. It is mostly possible to work so. So I'm reading Jan's comments. I always try to avoid branching, but there are 2 rules. 1, at least 1 commit a day, and 2, only working code is allowed in trunk. It's mostly possible to work so. So I think that is really, really difficult if there are like 5 or 6 or 7 people working on the same project. So I have a hard time imagining that to be working due to different reasons. So if everybody does that, 5, 6, 7 people, so that would be 7 commits a day. That would mean for me probably to have to restart LabVIEW 7 times a day to make sure that I don't have anything in memory that might get overridden. So for LabVIEW, I think it's difficult. Okay, so let's get cracking. Alexander tells me 10 minutes warning. Let's see. Let's make a small recap. What did we talk about? The mainline branch strategy, a single shared branch that acts as the current state of the product. It's good that it's a simple concept. It's always deployment ready if we make sure it's deployment ready. So we would have to have proper testing structure to make that sure probably. And the deployment works best for non-monolithic software. I didn't really know what term to come up with here. What I mean is like a website and not an application. If I want to deploy a small feature to a website, I can do that at any time. The next time a user loads it in the browser, it would be there. If I'm thinking about a test application for a customer, I can't send them 10 EXEs every day. So this continuous deployment doesn't really work. And this could be continuous, by the way. So if there was some process in the background acting on each of these commits that we do here, we could continuously integrate very nicely. And then we talked about branch-based strategy, where we said, okay, we need additional types of branches. We want them to be up to date with the mainline, of course. So there's some more maintenance needed. And usually those would be feature branches and an integration branch. That's the most usual way of working. Parallel development is possible with that. It's the upside, deployment ready code, but we don't have to deploy everything because we have the integration branch and then we have our mainline. Of course, the more branches we have, the more maintenance we have to do, and we need a naming convention. So even though I think this method is superior to the other one, it is more work to do that, obviously, but still it could be done continuously. So I think that's a plus. And then the next one I called deployment-oriented strategy. So this is where we liked, or how we like to work. So we have a feature freeze via additional branches. We can test our stuff in those branches, release branches that is, and then we can deploy to the main branch. So this is kind of the last schematics that we saw with the mainline, the development, and the feature branches. Maybe with even a little bit more system applied to it. And this is good if you don't want to deploy continuously, because deploying here would be creating a release branch testing what's not been tested before, doing, I don't know, integration tests, whatever, and then releasing that version into the wild. So the upside of that is it does not require the extensive testing infrastructure that we would need for the other ones, because we have one separate path we do use for the actual testing. Of course, it is better if it's automated, no questions asked. But the whole workflow model lends itself better to a situation where we don't have such an extensive testing infrastructure. Then the other thing is the process itself is very familiar. So it's usually that we develop something, then we test it, and then we deploy it. And that's kind of similar with the like more complex models. You would have your development, your feature branches, then you have your release branch, and then you have your main line. So I think that's easy to understand the concept. The convention defines clear starting points. So even though it is more complex, it is like a small and very concise set of conventions that we need to say, if you want a new feature, you start from develop. So it is a rule that we need to adhere to, but it's probably easy to follow it. And then this one is also good for release by version software. So that's the opposite of the one that I said before. I think creating a dedicated version, a release every now and then can be done very nicely with this strategy, but it's a lot of overhead, especially for new developers. So if you see, for example, Git Flow, which is one example of these things for the first time, there's lots of stuff going on and it looks intimidating. In our experience, that fades away. So most of the time, people don't really have a problem with that. This one here is not continuous anymore by definition, because it's deployment oriented. I want to deploy only sometimes. But with that being said, of course, we can do stuff continuously within our feature branches, for example. So only because the whole thing, like the end-to-end chain is not continuous, not everything, parts can still be continuously done. So we can have continuous integration in our feature branches, maybe, not so much then merging the feature branches into develop or creating the release. So there are some more slides about supporting technologies, and I'll just go through those very quickly because I think they're not so important. We've heard semantic versioning before today. That's the major minor patch system. If you don't know about that, look it up on semver.org. We have lots of CI providers out there, GitLab with the GitLab Runner, GitHub, Azure DevOps, Atlassian Bitbucket, and then Jenkins, which can be used with most of the source code control systems out there. It's a separate product, whereas most of the big ones by now already have their own system. So GitLab has had its GitLab Runner for quite some time. GitHub Actions and the Runner are quite new. Azure came a few years ago. So there's lots to choose from. Something for everybody there, I would say. Virtualization is an important thing when talking about build servers. So we use virtual machines on a virtualization server here in our office. We have one virtual machine per LabVIEW version, which works out nicely for us. And even our developer Windows installations are inside virtual machines. Ethan says Jenkins is clearly the best tool, no bias or anything. I agree, but the best for what? That's highly debatable, I would say. So I'm not trying to be dogmatic, but I agree, probably not to agree. So containerization, another thing, Docker. Probably you guys have heard of Docker, open platform developing, shipping, and running applications. It allows to package and run an application in a container. What is that? A container, a loosely isolated and lightweight environment that contains everything needed to run the application, which is difficult for Windows and for Windows applications because it comes without UI. So that's one obstacle. People have been making great progress. We have some links here. Chris Stryker has been working on that. Felipe has been working on that. So progress is being made, but I think we are not quite there yet. And the real life example that I had prepared for you guys is actually how we work. We use Git Flow, and now we can see down here that on top of Git Flow, we have the rule that before we merge our features back into develop, we want to have a merge of develop into the feature so that we can clean up every conflict that might happen in our feature branch before then merging it back into develop. This system works extremely well for us, extremely well. I'm totally happy with it. And we've been using that with customers for a few years now, more than one customer with teams around like 3 to 7 people in that size. And I always claim that I can count the number of unexpected merge conflicts on one hand. And I think that's still the truth. The one rule that we have is we never merge VIs, so we only merge branches. And sometimes conflicts can't be helped, of course, but usually we can work around them by communicating. And this is what the Git history would look like in a UI, and in a UI client, Git fork in that case, so we can see some feature branches being merged here. We make a point of seeing the merge commits. We don't rebase, we don't fast forward. I want to see what's happening in the history. That's what I have it for. But that's again, highly HSE specific. And of course, we have our release automation tools. So we have a set of VIs. It's a product that you can buy that we are using ourselves, that some of our customers also use. And what these tools do is they can take care of most of the needs that we have, which is validating DKMH modules, running VI analyzer, running unit tests, creating documentation through the awesome anti-doc toolkit by Olivier Chaudin from Wovolab. Also, for example, documenting, creating the charts for our state machines, then building source distributions or EXEs or real-time applications, whatever, building NI packages, building VI packages, and copying them to our own distribution platform. In our case, it's a web platform, a wiki, where we then can download our updates from. Okay, so with all that being said, it's 6 p.m. now, so I've used up my time. I want to give you some takeaways. All that runs automatically is in CI. Keep that in mind. Automate the good process only. Choose your workflow wisely, but choose one. So it doesn't matter which one you choose. It's not every shoe fits every foot. So pick the one that you like. Some seem to be a better fit with LabVIEW than others, is my impression or our impression. Every single workflow benefits from QA. So static code analysis, unit testing, documentation generation, custom validation tools, all of these, of course, they help your case. They are great. And it doesn't matter what it's called if it works for you. So yeah, with that being said, some resources, I don't know, do we share the slides later on? So take a screenshot if you like. And don't forget, it's okay to have fun. Thank you very much. I'm not sure how the chat works here, but maybe if we can stay in this room, I can answer some more questions here. If not, please feel free to reach out to me. I'm sure you're going to find me. I love talking to people, so don't hesitate to send me an email or send me a message on LinkedIn or whatever. I would love to talk to you. Thank you, guys. So I'm seeing Tony Vento of the updates. What are the biggest improvements in the last year? Product and best practices. Well, that takes more time to answer. Tony, I hope we can have a conversation soon. So maybe let's try and make that happen. Okay, no more questions. So I would have hoped to discuss more, but the problem here is, of course, that it's a one-way road. So I'm talking to my screen more than anything. So Mike says you don't merge VIs, just full override from the branch to the main. Yes, that's correct. So if there are, as I said, if there are merge conflicts, usually we have anticipated them because they should not happen. And Oh, my camera is overheating. That's nice. So we would then pick the one that we want to keep and just override. So either the one or the other. Up to 5 people can request to share video audio. Okay, cool. I can approve them. How can I do that? There are some little plus signs. Didn't get that. So what are other questions? Let's see. Yeah, I think Vive did some advertising for source code control. I mean, that's a given, really. There's no living in software land without source code control, is my opinion. And once you use it, you'll never want to go back. I'm sure of that. For any other stuff, as I said, again, send me an email. Do you have any set of rules for collaboration, how to divide work? Using libraries is a must, but what about shared resources, type tests? So Zoltan, we have our Doku wiki. Alexander, maybe you can share the URL to the best practices section, where we collect all of our, yeah, like I said, best practices. It's also a knowledge base, and we even use it for customer communication and collaboration. I guess I can share. Can I share my screen once more? Let's try it. I think I need to move it here again. Share the screen. Yes. Move it away. So there you can see our Doku wiki, and in our, well, we describe all of our code. So these are all of our open source projects that we share with the community. So feel free to collaborate on these. And then we have our best practices section, and we have coding conventions, for example, about style, about the architecture, layout and design, etc. And also we describe our way of working here. So how do we set up our machines? What is the structure of our repositories? What is the workflow that we use? So there is some guidance for both people from the community who want to collaborate, but also for our customers, for new team members, etc., etc. Shared resources like a type def. I don't think that this is mentioned here specifically, Sultan, to get back to your question. But I do think that there is some higher level guidance here in terms of dependencies, etc. But that's a topic on its own, I would say. Coming back to the question of Roger, if you want to implement more than just automated unit and VI analyzer tests, how do you realize automated UI tests with LabVIEW together with Jenkins? So we use GitLab, and GitLab comes with its own CI machinery. We have build servers that run the GitLab runner, which is a small application that connects to the GitLab server, to the source code control server. And if defined triggers happen there, the GitLab server will let our build server know that there's something to do. So we have our own set of tools implemented. So depending on what the trigger event is, we would run only the tests and the build process, etc., etc. So that's the way that we do it. Awesome. Okay, I think we're through. So again, thank you very much. Any more questions? I really invite you to get in contact. We love talking to people and have some elaborate discussions about stuff. And thanks again, everybody, for participating, and have a nice evening. Enjoy the rest of the GLA Summit, and see you guys in 1 hour, hopefully, for the DQMH panel discussion. Bye, guys.